One of the other types of unique equations that we have in VCE methods is a circle, and it's unique for a key reason, and it's because a circle is not actually a function. It's a relation, and that's because it doesn't pass a vertical line test, or it has multiple x values for multiple y values. So the most basic form of a circle is x squared plus y squared is equal to 1, and for any circle, not limited to just this circle, but any circle has a radius and a center, and they're the key things that we need to look out for when knowing how to sketch them on a Cartesian plane. So for the most generic form of a circle, the radius is going to be equal to 1, and the center is equal to 0, 0. So how do I get these from the general form? The radius comes from this value here, and you might see just the generic form of a circle written as x squared plus y squared is equal to r squared. So this circle still has a center at 0, 0, but then the radius is just equal to r. So you just take the square root of whatever value is on the outside, and then that's your radius. So in this case, it's the square root of 1, which remains as 1. If it was x squared plus y squared is equal to 4, the radius is going to be equal to 2, because that's the square root of 4. So in this case, 1 means a radius of 1 on the outside, and sometimes you'll see it sometimes written as x squared plus y squared is equal to 2 squared, or in this case will be 1 squared, just to be clear that this bottom number is equal to the radius. Now the center is equal to 0, 0. How that's integrated in this equation here is with no x or y translation. So if you did have a shift in the x or y direction, you'll have a value added or minus to the x before you square it. So we'll go through that example in the next part of this video. So in this case, what's going to happen is that you have a center at 0, 0, and the center is not actually a part of your graph, or it's not a part of your curve, but it's still important to note when you're sketching anyway. So the extremes of this graph are going to be at -1, 0, 1, 0, then you have 0, -1, and then you also have 0, 1. So these are going to be the extremes of your circle, and then you just connect, arcs either way. How I personally like to sketch circles, just to make sure that I limit the amount of bad potential that I have when sketching, is I like to draw vertical lines here and then horizontal lines there, because I know at the extremes of the circles, they're going to be kind of turning points. Even in the vertical direction, you still have turning points as well, and then it's really easy to just connect those arcs. So I connect that like that, I connect that like that, connect that like that, oh no, and I connect that like that. I kind of cooked that top left line. That's all good. Let me just redo that, but you get the point. I think it's much easier to sketch on paper than it is on the whiteboard. I'm also trying to stay away from the whiteboard to ensure that I don't smudge anything else, and this graph is not the best, but you can see the idea is kind of right there. So let's move on to a more complex equation. Let's just do it now. It's actually fine. I don't have to create a separate video for it. I could just do it now, make up some numbers on the spot. So let's do a more complex equation where we have an example with x minus 1 squared plus y plus 2 squared is equal to 9. So let's read off all the key features. The first one we talked about was the radius. The radius is equal to the square root of 9, which is equal to 3. And you usually note that this is most commonly going to be a perfect square, just to make it a bit easier to calculate your numbers. So this one is a perfect square, which makes it a lot easier to deal with. And the center is going to be kind of dictated by our x and our y translation. So in this specific case here, we have -1 on the x, which means we have a translation to the right by 1 unit, because we know it's opposite for translations that happen inside the function. So the x value is going to be +1 for our center, and then the y value is actually going to be -2. This is something that we don't see very frequently in VCE methods, is that the y translation, you take the opposite sign as well. But if you think about how transformations are applied, it's an adjustment to the y value specifically here, and it's inside our equation or inside our y term. So therefore, we take the opposite sign as well, which means it's going to be equal to -2. So how I like to sketch it when you have translations as well as non-1 radius as well. It doesn't matter what the radius is, but whenever you have a shifted center, I draw the center first, so +1 and then -2, which is somewhere like there. And then I draw the extremes of the graph, which is what I did here. But you'll notice that as a result of my shift, I actually have x-intercepts, x and y intercepts, or axis-intercepts, that are not aligning with the extremes. So you can see here that I have y-intercepts here, x-intercepts there, but they aligned with my extremes, so I actually didn't have to calculate them separately. But in this case, because of the shift that I have in my center and the translations that I have in my equation, the extremes are not going to align with the axis-intercepts, so I have to calculate them separately, which is not too much of it's not too difficult, it's just more tedious than anything. So we have 1 comma negative 2 there. So we shift to the right by 3 units. So that would be 4 comma negative 2. So that would be somewhere like here, 4 comma negative 2. And then we shift to the left of our center by 3 units. So we have negative 2 comma negative 2. And then we shift down and up by 3 units. So we have downwards, which will bring us to 1 comma negative 5, just minusing the y value by 3. And then we add the y value by 3 to make it 1 comma positive 1. Sweet. So then what we do is we go ahead and create our circle. Hopefully this is a bit better than last time. Okay, it's looking a bit better now. Okay, that's actually not bad. I'll take that. Yeah, I'll take that. That's pretty good. Sweet. Now the last thing we need to do is just get our x and y intercepts. And as I said, this can be slightly tedious, but it's still a necessity to do for our equation. So let's do the x-intercepts first, which means that y is equal to 0. So you end up getting x minus 1 squared plus 0 plus 2 squared, which becomes 4, is equal to 9. X minus 1 squared is equal to 5. Therefore, x is equal to plus or minus square root of 5 plus 1. So we know that the positive version of our square root is going to be the more positive value at our x-intercept. So this value here is going to be 1 plus square root of 5 comma 0. And this one's going to be the more negative value, 1 minus square root of 5 comma 0. You can work it out in a decimal format just to kind of get a rough gist of where it is. Square root of 5 is roughly 2.2 or so. So you can figure out 1 plus 2.2 is roughly 3.2. But because we've already sketched our graph and we know where these coordinates already lie, there's really not much of a need to actually kind of work out a decimal value of it, because we already get a really good indication of where our circle lies just based on the extremes. The x and y intercepts are more so just to complete our equation. Let's just find the y-intercepts very quickly. Y-intercepts happen when x is equal to 0. So let's calculate it here. So we end up getting 0 minus 1 squared, which becomes positive 1, plus y minus 2 squared is equal to 9. Y plus 2 squared is equal to 8. Therefore, y is equal to plus or minus 2 root 2 minus 2. I don't know why I draw a bracket there. Sweet. So again, the more negative version is going to be the negative square root. So we're going to have 0 and then negative 2 minus 2 root 2, kind of a tongue twister. And then we have 0 and then negative 2 plus 2 root 2 as our final coordinate. And this would be our complete graph with a lot of information on it. So you have the extremes of the circle, you have your x-intercepts, you have your y-intercepts, and then you'll also have the center of the circle.